Now see this question. In this question we are given sets. Phi set A whose elements are 1 and 3, set B whose elements are 1, 5 and 9, and set C whose elements are 1, 3, 5, 7 and 9. And here in each case, okay, we have to insert the symbol this subset or is not a subset of, okay, proper symbol we have to insert here. So let us see the first one, phi and set B. And we know that phi is a subset of every set. So we will write phi is the subset of every set. Okay. Now set A and B. So set A, so 1 is an element of set A, also an element of set B. 3 is this element, 3 is one of the elements of set A, but 3 does not belong to this set B. So we will write it is not a subset of B. This A is not a subset of B. And why? Because this 3 belongs to A, but this 3 does not belong to B. Okay? This 3 belong to A, but this 3 does not belong to set B. That is why A is not a subset of B. Now what about A and C? So 1 and 3 are in set A as well as in set C. So we can write A is a subset of C. Okay, A is or we can say it's a proper subset, because here we have means element in set A, all the elements of set A are also an element of set C, and they are not equal. Okay, in C we have 5 elements, in set A we have only 2 elements. So here A is a proper subset of set C. And the next is B and C. So 1, 5, 9 we have in set B, and 1, 5, 9 also, all the 3 elements are also in element also an element of set C. So B is also a subset of or proper subset of C. Okay, generally instead of saying proper subset, we generally use this word subset only. So here and this phi is a subset of every set. Okay, so this type of question you will find in the next exercise. Now if a set is given, then how to find its total subsets? Okay, how to find subsets of this set A? I am taking one example. Here A is a set whose elements are 1 and 2. Now how to find subsets of this set A? So before you find the subset of set A, these 2 important points you have to keep it in your mind, which we have already discussed. The first thing, phi is a subset of every set. So in the list of subsets of this element, we will include phi, and a set itself, and a set is itself a subset of, okay, a set is also a subset of itself. Okay, so here we'll also include this set A. If you want, you can write A, or instead of writing A, you can write this whole set AB 1, 2. Okay, so in the list of subsets of this set A, first we'll include phi and the subset itself. Okay, and then after we'll write element individually. Okay, so first this set of 1, which is a subset of A, and set 2, which is a subset of A, and this combination of 1 and 2. Okay, which we have already written, so we will not write again. Okay, so here we have 1, 2, 3 and 4 subsets of set A. Now there is a formula to find number of subsets of a set, and the formula is 2 raised to the power n, where this n is total number of elements in a set. For example, this one, set A. So here there are 2 elements in set A. Okay, so n will be 2. So the total number of subsets, 2 raised to the power 2, 4. So let's check whether we have 4 subsets or not. 1, 2, 3, 4. Yes. Okay, so this is correct. So either you write A or you write 1, 2. Okay, it's better if you write 1, 2. No need to write this A. Either write A or this one too. Now let's take one more example. Set A is equals to 1, 2 and 3. So here total number of elements 3. So total number of subsets 2 raised to the power 3 means 8. So there should be 8 subsets of this set. Now how to find these 8 subsets? So in the list of subsets, first we'll include 5 and the set itself. Okay. Now each element individually. So set of, it's compulsory to write this bracket. Why? Because a subset is itself a set. Okay. Subset is also a set. Okay. So that is why this bracket is compulsory. So first set 1, set of 2, set of 3, then pair of 2, 2, set of 1 and 2, set of 1 and 3. Here 1, 2 and 2, 1 both are equal. Okay. Both are same. Because in set, order doesn't matter. So 1, 2, 1, 3, then 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8 subset of this set A. Okay. So we have discussed, means that 3 important points, that phi is a subset of every set. Then next point, every set is a subset of itself. And third point, every subset is also a set. Okay, every subset is also a set. Now in our number system also we have so many sets: set of natural numbers, set of integers, set of whole numbers, set of rational numbers, set of irrational numbers, set of real number. So when you observe, you will find that set of natural number is a subset of set of integers. Okay, or this set of integers is a subset of set of rational numbers, and set of rational number is a subset of set of real number. Okay, so in this way, n is the subset of integers, which is a subset of rational number, which is a subset of real number. Okay, this is a relation among these sets: set of natural number, set of integers, set of rational number, and set of real numbers. Now next is power set. Next is power set. So power set is a collection of all subsets of a set. What is power set? It's a collection or set of all the subsets of a set. For example, a set is given whose elements are 2, 5. So power set of set A is represented by capital P and then A. Now what is power set? So power set is a collection. Okay, it's a set of all the subsets of this set A. So now we will find all the subsets of set A, and the set formed is called the power set of A. So how to find subset of this set A? So phi, first we'll write phi and the set itself. Okay, then individual number, individual set. Okay, and then, so that's all. Okay, there are 2 elements, so 2 raised to the power 2 means there are 4 subsets. So all the 4 subsets we have written here. So the collection of all the subsets of a set is called power set. Okay, and when you observe, you will find that every element of a power set is a set. Okay, they all are set. So if we write it like this, then this 2 and 5 are called elements. Okay, and this is power set, and these are elements of this power set. So these elements of power set are also set. So important result: every element of a power set is a set. Okay, every element of a power set is a set. Why? Because power set is nothing but set of all the subsets. Okay, they all are subsets, and we know that subset is also a set. Okay, so every element of a power set is a set. Now next is intervals. Okay, we'll discuss different intervals. So the first comes open interval. Okay, open interval. So if I say this A belongs to A comma B, then this bracket is called open interval, and it means that, let it be x belongs to A comma B, and this interval is called open interval. It means that if A and B are here is A and here is B, then this x lies between A and B, but when we write the values, we will not include A and B. If x belongs to open interval A and B, it means we will exclude this extreme values. Okay, means excluding this A and B. So if I write this x belongs to 1 comma 5, then the possible values of x, here we will exclude this 1 and 5. So excluding 1 and 5. And if I say this x belongs to it's a natural number. Okay, so x belongs to 1 comma 5. So if it is an open interval, then we will exclude this extreme values. So we'll write the possible values of x 2, 3 and 4. Okay, I'm just giving you an example. So if x belongs to A comma B, open interval A comma B, then we exclude this extreme values. We will not include A and will not include this B. So how to write? So in that case, we will write this x lies between, when this x is greater than A but less than B. Only less than greater than symbol. Okay, it means this x lies between A and B, means excluding A and B. And if it is closed interval, then this is the symbol for closed interval, a closed bracket. So in here we just exclude A and B, and here we will include A and B. So if x belongs to closed interval A and B, it means if A and B are here, then we will include this A and B. Okay, it means we will write the value of x is greater or equal to A and less or equals to B. So from this symbol also, means you will be able to identify whether it's an open bracket or open interval or closed interval. If it is equal, then it's closed interval. Less or equal, greater or equal, then it's a closed interval. Simply less or greater than, it's an open interval. So in this case, if I write x belongs to 1 comma 5, means we need to include 1 and 5. So here the possible values of x 1, 2, 3, 4 and 5. Okay. Now next is semi-open. Semi-open means half. Okay, half open. Suppose if I write A comma B, so this is open from this side, so that is why it is called semi-open interval. Okay, so in this case we will include A but excluding B. So here this x is, if I write x belongs to this semi-open interval, it means that x is greater or equals to A but less than B. Okay, and next is semi-closed. If it is semi-closed, means open from one side and closed from the other side, then the side from where the bracket is open, we will exclude this extreme value, means excluding A but including B. Okay, so semi-open and semi-closed. So these are the intervals. So on a real number line, if we denote this semi-open interval, then these are A and B. So we are including A and excluding B. And here we are excluding A but we are including B.